Good evening and good morning, everyone. Welcome back to online session on Azure Administration. I hope I'm audible to all of you and my screen is visible to all of you. Great. So we are going to continue with module number 6, where we are going to understand administering network traffic. So let me start this module and let me show you lessons which we are going to learn in this module. Load balancer. We are going to discuss about load balancer. We are going to discuss about application gateway. We are going to discuss about network watcher, which is a network monitoring tool. And then this module will be complete. During the session, we will do hands-on labs as well. So let me start lesson number 1, configuring load balancer. When it comes to load balancer, first of all, we have to understand what is the requirement of load balancer. Correct? So when it comes to HA, high availability, so assume we are deploying a application. So assume I'm going to deploy a 2-tier application. So where we have front end and database. So which we deployed on a same server, that is on a single VM or single server. What if server fails? If hardware fails, it means both components stop working. It means there would be downtime for your application. So what you will do, you will create a architecture where you will use 2 virtual machine, one for front end, that means for your web application, and second for database. One virtual machine for front end and one virtual machine for database. 2-tier architecture. Into Azure, if you are going to do that, so if I'm using Azure virtual machine, so I will get 99.9% SLA, 3 nines SLA from Microsoft. So what I want, just because of SLA, this would be my business critical application and I have to increase my SLA or I need to decrease my downtime. How I can do that? So what I will do, I will create more than one identical instances for my web application, that is for front end, and similarly I'm going to create more than one database instances which will be identical, like master and standby. Correct. Now this will increase your SLA. Now whenever you will create a HA, high availability, if you are deploying more than one instances, so how you will distribute your traffic which you are receiving from internet. So end users who are sending requests to your web application, how you will ensure that your request will be distributed to all servers or endpoints. So what we can do, we will deploy a load balancer in front of your web applications. So your web applications will be added as a backend to this load balancer. And there would be a front end on your load balancer if your load balancer will be a public load balancer. So when it comes to load balancer, we can create 2 types of load balancer, public and internal. So if it would be a public load balancer, it means connected to internet, then you will get a public IP address on your load balancer, which is known as front end IP address, and this would be front door for your end users. So end user, they will send request to your load balancer public IP address, where you can use your custom DNS as well. Hope you all remember DNS lesson. So where we can create a custom DNS in which we can create a record for this public IP address. So your load balancer will receive this request. Load balancer will check its load balancing rule, in which you will define a rule, your source port, source protocol. Correct. So if users are sending requests on port number 80 or port number 443, then I will entertain this request, and then load balancer will distribute this request to all backend resources based on the round robin algorithm. Round robin. Any idea what is round robin? Any idea what is round robin algorithm? So round robin means load balancer will distribute incoming requests to backend instances evenly. Correct. So it means first request will be sent to first server, second will be sent to second server, third, then fourth, then fifth, and sixth. So load balancer will distribute your requests evenly. That is called round robin algorithm. Correct. So where we are going to use load balancer. So in Azure we have standard load balancer which we are going to understand. But before going to understand load balancer, we need to understand load balancing solutions into Azure now. What different types of services are available, which we can use. So first of all, application gateway. As name state, application gateway. So it means it will work on application layer 7. That means if it works on application layer, it means it supports HTTP and HTTPS based request. So optimize delivery from application server farm while increasing application security. How? Just because you can use web application firewall, which will protect layer 7 request content. Protocols which you can use HTTP, HTTPS and HTTP2 WebSocket. Private, that means it's a regional service. Yes. Global, no, there is no global service available. That means there is no global application gateway available. Environment where we can use for Azure, for non-Azure cloud or for on-premises. Security, web application firewall we can use in front of our application gateway, which would be optional. So optionally we can use. Next option is front door. When it comes to front door, so front door means, before going on front door, let me go to Azure Load Balancer. We'll discuss front door at the end of this discussion. So load balancer, which is a layer 4 load balancer. If it works on layer 4, it means it will entertain your request on TCP and UDP. That means port, protocol and IP address. Based on that, so it will entertain, it will distribute your request. So balance inbound and outbound connections and requests to your application on server endpoints. Protocols which are supported, TCP and UDP. Private, yes, we can use within the region, and nowadays globally is also available. Correct. Environment within only for Azure resources like Azure VM and Azure VM scale set virtual machines we can add behind this load balancer. Except in Azure virtual machines or virtual machine scale set virtual machine, we cannot add any other resource in backend pool. But in application gateway, you will get granularity where you can add Azure virtual machines, non-Azure cloud virtual machines, or on-premise virtual machines as well, on-premise virtual machines, on-premise physical server also you can add in behind of your application gateway. When it comes to traffic manager, now what is traffic manager? Traffic manager, let me add a slide here just because we have only comparison here. In depth, you will learn about load balancer and other front door and traffic manager into your Easy 700 certification. So assume one situation where we have two regional endpoints. Correct. Assume I'm using application gateway. So here I have my servers, front end, back end, and here I'm using application gateway into US East. Then I have another site into Central India where I have same infrastructure, that is replica of my East US web application. So what I want some service into Azure which can route my traffic either to East US or to Central India based on the routing algorithm. So into Azure now, if I'm talking about AWS, so in AWS we have a service which is known as Route 53. That means DNS plus routing service into AWS, which you will get, which will route your traffic, and you will get DNS feature as well. Now into Azure we have a service that is known as Traffic Manager, in which you will get DNS endpoint. That means you will not get any public IP address, you will get a DNS endpoint, and it's a global service. So you will use Traffic Manager, and in Traffic Manager you will create your endpoints, regional endpoints, US East, Central India, correct? And after then you will use routing methods, where you can use performance-based routing, priority-based routing, weighted-based routing, subnet-based routing, geolocation-based routing, correct? So what I can do, I can decide like what type of routing, or as well as disaster recovery. Disaster recovery I can also configure, like I can decide that this would be my primary site, this would be my secondary site. So whenever I will receive requests from internet on traffic manager, all requests, that is 100% requests will be sent to my primary site. If primary will be down, then I'll do failover to secondary. Correct, where traffic manager will do your health check also to both endpoints, and you will receive request on secondary endpoint. This will be done by a traffic manager. Or what I can do, based on the geolocation also, I can redirect my request. So if I'm receiving request from US, I can send all the requests request to East US location. If I'm receiving request from Asia region, so I can send to Central India to reduce the latency. So different types of routing algorithm I can configure, and based on those routing algorithm, I can configure traffic manager. So it distributes traffic to services across global regions while providing high availability and responsiveness. Protocol, any, it supports any protocol. Reason? No, it's a global service. Environment, it supports Azure, non-Azure, clouds, on-premises as well. That means here you will get renewability, and you will get routing. So basically traffic manager is a routing service into Azure. It's a routing service. Now when it comes to front door, now let's discuss about front door. So what is front door? Now what I want web application firewall feature globally. So web application firewall only supported on application gateway previously, correct? And it's a regional service. Application gateway is regional service. What I want some service which should be global, and where I can implement web application firewall, as well as I can do path-based routing. Now what is path-based routing now? So path-based routing, URL-based routing, or content-based routing, all are same. So what it is, so let's assume again a scenario where we can use path-based routing. So now I have a application which would be an e-commerce application where we have home tab, and for home tab I'm using, let's assume, container services, Azure Container, ACI, Azure Container Instances. Now I have a tab which would be product. So for products I'm using, let's assume, Azure Virtual Machine. Then I have a tab which would be orders. So for orders tab, again, I'm using, let's assume, Azure Web Applications, App Services. That means PaaS resource. After then, there's a search tab, and for search tab, I'm using Lambda function. Sorry, but it calls Azure Functions, not Lambda function, Azure Function. So Azure Function, which I'm using for search, and there's a Payment Gateway tab, where I'm using on-prem server. So what I want, like in home tab, I'm using assume 2 containers. So for products, I'm using 2 virtual machines for high availability. For orders, I'm using 2 web applications, again for high availability. For search, I'm using Azure Function. Payment gateway, I'm using either 1 server or 2 server, it depends, on-prem server. Now where what I want, whenever I will receive a request from internet, assume my website is www.xyz.com. So any user who is sending requests to my load balancer, which is my application gateway, load balancer. So if user is sending request to www.xyz.com/orders, correct? So this request will be received by application gateway, where we have created rules based on the path. So application gateway, it will read your application layer 7 content. That means your URL content. Correct? It will read your content, and based on the request, it will distribute your request to correct pool. That means to order pools. Similarly, any user who is processing for payment, so it means in URL it will read payment and then request will be sent to payment gateway only. So this will be done by application gateway only into Azure. That is known as application gateway, path-based routing, URL-based routing, content-based routing. Correct? This will be done by application gateway. So what I want, my requirement is I need a resource which can do path-based routing on globally. Correct? As well as web application firewall, as well as routing. It means features of application gateway, features of traffic manager. I want. So you will get features of traffic manager and application gateway into front door in one service, which is a global service. Scalable, just because it's managed by Azure. Security enhanced delivery, point for global microservice based web application where we can use container services. Protocol, it supports again, as you can see in application gateway, HTTP, HTTPS, HTTP2 WebSocket. Reason, no, it's a global service. Environment, again, as compared to application gateway, it supports same environment, Azure, non-Azure cloud applications or on-premise virtual machines. Security, we can use WAF as well as network security group, web application firewall and network security group, as well as you will get routing features also similar to traffic manager, and you would be able to route your traffic to multiple regional endpoints where you can use application gateway or load balancer, depends on you. So that is difference between all routing solutions. So I describe in depth so that you all can understand, otherwise we have only introduction here in our slide. Correct? Hope this part is clear to everyone. If you have any query, you can ask a question. Let's move to next part.
Sanjay, sorry. Hello.
Yeah, please go ahead.
Sorry to interrupt. I just have a question with regards to uh the similarities between the load balancer in Azure and also the ALB or NLB in AWS.
Hmm.
Can you give some similarities or maybe their basic differences?
So if I'm talking about ALB, so it means I'm talking about application gateway into Azure, which is similar to AWS ALB, application load balancer. Correct? When I'm talking about network load balancer, so network load balancer which works on network layer, again that means it supports TCP
Okay.
protocol.
Okay.
Correct?
Okay.
Port protocols and IP address.
And also in NLP they have um what do you call this, AWS Shield. Does
AWS
Azure?
Shield, yeah.
Yeah.
So again, if we will compare with AWS, so in different, we have here web application firewall, they have AWS Shield, correct? So again, like clouds is different. So services, security services and security features will be different in different clouds,
Uh,
correct?
does Azure have a similar
In Azure, we have
feature?
web application firewall. Okay, so through which you would be able to protect your layer 7 content from cross-site scripting, from
Mhm.
SQL injections, from DDoS, correct? And again, it use OWASP top 10 rules.
Okay, because in NLB, right, they don't have WAF, so they
Uh,
use AWS
yeah,
Shield.
so in
Okay.
ALB, in
Yeah.
AWS, NLB, there is no OWASP. So either I
Okay.
can use any VAPT tool where I can use OWASP, that means external tool, if I want, into AWS.
Got it. Yeah. Thanks, Sanjay. Yeah.
Let's move to next part, implementing a public load balancer. When it comes to a public load balancer, when it comes to load balancer into Azure, it means we are talking about a legacy standard load balancer. It supports port 80. So it means users who will send requests to your load balancer will listen request on port 80. It means what if I want encryption, that means HTTPS, SSL. So that is not supported on standard load balancer. So maps your public IP address and port number of incoming traffic to the VM's private IP address and port number and vice versa. What it does mean? It means user will send request on some port like port 80. So and user will send request on a public IP address. So public IP and port which will receive on your load balancer. Load balancer will distribute this request to private IP address of virtual machine and port number 80 or port number 80. That is called load balancing, standard load balancing into Azure. Apply load balancing rules to distributed traffic across VMs or services, and how load balancer will decide which port and protocol your load balancer will entertain. You have to create load balancing rule in which you will define that you will listen port number 80 and which you have to distribute to backend resources, which would be your virtual machine. That is called public load balancer. Similarly, we can create internal load balancer. When it comes to internal means it's simple to understand. That means which will not work on internet. There would be no public IP address on your load balancer. So within the VNet, it will work. So this would be your two-tier application architecture where for front end, for web tier, there would be a public load balancer and your virtual machines, that means web applications will be connected to front end, and then it will receive requests from internet on port number 80, which will be distributed by your load balancer to your backend virtual machines, that means web applications. Web applications are connected to your internal load balancer, and they will send request to internal load balancer on private IP address. That means you will get multiple front ends into internal, which would be private IP address of your virtual machine, and then web application virtual machine. And then your internal load balancer will distribute this request to your database on port number 1433 or 3306. It depends which database engine you are using, SQL, MySQL, Postgre. So depending on that, you will open your port into your firewall. That means into NSC, you will open that port. That is called two-tier architecture, where internal load balancer works within the VNet only, between your subnets. So direct traffic only to the resource inside virtual network, or that use a VPN access Azure infrastructure. Again, using VPN, it means I'm going to access my private infrastructure. Front-end IP address and virtual networks are never directly exposed to an internet endpoint. So there would be no public IP address on your load balancer. Enables load balancing within our virtual networks or cross-premise virtual networks or multi-tier application for line of business applications as well. That means if we have two-tier, three-tier application, so in between my tiers, I can use load balancer if I'm going to use more than one identical instances. I'll definitely use internal load balancer to distribute traffic between my tiers. Again, when it comes to load balancing, that is standard load balancer into Azure. Features, so we have two SKUs, basic and standard. When it comes to basic, we would be able to add 300 instances behind our load balancer as a backend. Health prop, we can configure using TCP and HTTP protocol. When it comes to standard, we would be able to add HTTPS and TCP protocol for health check only. Remember, health check only. When it comes to standard SKU, we would be able to add up to 5,000 instances behind our load balancer. Availability zones, so no availability zone deployment is available. It means multi-AZ deployment is not available. So if multi-AZ deployment is not available, it means you will not get any SLA from Microsoft. So as we'll check here, SLA not available. There's no SLA. Multiple front ends only for inbound requests. We can create multiple front ends. Secure by default? No. By default, that is open onto internet. Later you can use your NSC. When it comes to zone redundancy for standard, yes, you will get zone redundant load balancer and you will get 4 nines SLA. It will be where you would be able to use inbound and outbound front ends. Close to inbound connection, NSC you can use to open your connection, open your request on particular port and protocol. Creating load balancing rule. So rather than reading slides, let me show you lab in which we are going to create rules and we will understand this load balancer as well. So how we will test this, let me show you. So for this, I'm going to create a scenario, so which we are going to perform, and we are going to test this scenario. So I will create one VNet 1, in which I'm going to create a subnet, which would be web subnet, where I'm going to create two applications which would be identical, web 1, web 2, and here we will place our load balancer, correct, and you will get a public IP address on your load balancer as front end. I will create one storage account as well. So why? To save my time to perform this lab. How? So in storage account, I will create a blob container in which I will add a PowerShell script. Yes, PowerShell script for installing web server inside my virtual machines. Like into AWS, you can use user data for your instances. So whatever commands you will execute into user data, means you will provide into user data, those commands will execute whenever your instance will be ready in background, correct? So you don't have to execute those commands manually. Similarly, what we can do, we can use extensions feature into Azure, which you will get on Azure Virtual Machines, where you would be able to run PowerShell scripts. Let me show that how we can do that. So one server, one virtual machine, I'm going to configure manually so that you would be able to understand manual as well as using extensions. Second, we are going to use extensions so you can understand both. So let's check this lab. So let me go to my portal. Let me search first of all storage accounts. We have a separate module for storage account, and storage account is not our objective. So with basic, that means recommended configuration, we will deploy our storage account. Let me create a storage account here. So click on create. Let me create a new resource group, which would be M6RG1. Storage account name, it should be unique on internet. So globally unique. Why? Just because this name will be included into your URLs. Correct. So whatever name you're going to assign to your storage account, it should be globally unique. Let me show you. Like I'm going to create here Sanjay Cognitia and Azure. Sanjay Cognitia. Let me check this name is available or not. Sanjay Cognitia Azure. Let me use this name. So this would be available. Then region will be Central India. Rest I'm leaving as it is. As I already told you that we are going with recommended settings. Basic. Correct. So you have to create a resource group. You need to provide a name which should be unique on internet using Azure DNS suffix, and rest you need to leave as it is. Click on review and then click on create. Click on create. It will be created. In few seconds, your storage account will be available. As you can see, storage account deployment is done. Let me go to my storage account, and then left hand side you need to go to data storage. Under data storage you will get containers, which is basically for blob data, blob containers. Let me click on create container, add container. Container name scripts, you can give any name or totally up to you. Click on create. So create one container. Container is a logical unit here, so it's similar to folder, like you're creating folder. Let me open this container and let me upload my PowerShell script for my local system. Same PowerShell script I will upload into Google Drive. Correct, so that you all would be able to test this lab. Let me check where is my script. So web PS1, I'm going to use the script. Let me open the script. Let me click on upload and let me show you commands. So let me click on edit here. As you can see, first of all, we are going to install role of web server including management tool, that means feature dependency. Correct. After that, we will remove HTML document from this path, the default website. And after then, we will execute a command which will create again a HTML file in which it will print your computer name. Simple script which we are going to use as an extension, as a user data for our virtual machine. Now let me show you how we will use this. So I'm going to create a virtual machine, web1 first. Let me click on create as a virtual machine. Resource group existing M6RG1, virtual machine name web1, region Central India where we have our storage account, availability zone, no infrastructure redundancy required here. Image, I'm going to use Windows Server 2022 data center hot patch. Then scroll down here, size, I'm going with default size, username, student, password, 12 character and complex password for your virtual machine. Confirm your password. Next, go to networking tab. After username and password, go to networking tab. On networking tab, customize your VNet. So click on create. VNet name, VNet1 as per our scenario. Address, I'm going with same address. First subnet name will be web subnet. That's it. Click on OK. Next, go to advanced tab. After networking, you need to move to advanced tab. On advanced tab, you can see there is a tab extensions. So extensions means what? If I have to install any driver inside my virtual machine, so how I'll do that? Like GPU driver or any monitoring agent or any backup agent, other agents, correct, which I have to install anti-malware agents inside my virtual machine. So first I will install my virtual machine. That means I will create my virtual machine. After then I will get a console, that means using RDP or SSH. After then I would be able to install those tools inside my VM. What we can do, we can use extensions. So whenever your virtual machine will be ready, available, whatever extension you will select, it will be installed in background and where you don't have to install manually. So let me show you. Click on select extension where you can see agent for cloud workload protection, Symantec, which you can install. Agent for Windows Server monitoring, which you can install inside a virtual machine. So APM inside .NET agent, GPU agent. So there are lots of agents which are available, which you can select and install inside your VM without having console of your virtual machine. So if we have some PowerShell script, so what we will do, we will scroll down here. You can see here we have an extension here, custom script extension. We will select this option for PowerShell script. So select this option, click on next. It will ask you to browse your script file. Click on browse and it should be inside a storage account. So click on browse. It will ask you to select your storage account where my script is available into Sanjay Cognitia. Let me select this. Where I have a scripts container, let me select script container and let me select this PowerShell script. Click on select, create, and after then click on review and create your virtual machine. Click on review and click on create. Virtual machine deployment will be start and it will be completed once your extension will be installed inside your VM. Then your deployment will be complete. Meanwhile, I'm going to start deployment of second virtual machine, which we will set up manually. So let me go to virtual machines tab. Let me click on create Azure virtual machine. Resource group same, M6RG1. Virtual machine name, web2. No infrastructure redundancy required. Username, student, password of your VM, confirm password. And now next go to disk tab, networking. On networking, you should select your existing VNet where you can see I'm not able to see my existing VNet. So let me wait for my previous deployment which is going on, which you can see here. So let me go to my deployment tab where you can see still that is in under deployment where VNet is already done. VNet deployment is already done. So let me open duplicate tab and let me try from duplicate tab. Resource group existing, virtual machine name, web2, region, central India, same reason, no infrastructure redundancy required, virtual machine image, Windows Server 2022, username student, password for virtual machine. Go to networking tab and let's check. Now I'm getting my VNet, existing VNet, VNet1, where we have web subnet. So let me now click on review and create. In this VNet, we are not going to use extensions. So I'm going to show you manual process. So in first virtual machine, we are using PowerShell script. In second VM, we are going to set up second VM manually. And same PowerShell commands I'm going to execute. Let me open those commands. So as you can see, deployment is started. Any idea what if we are not able to access our Azure Virtual Machine and we have to execute PowerShell script? So what different ways are available through which I can execute PowerShell script or PowerShell commands inside my virtual machine without having console? I'm not able to take console just because might be there would be no public IP address available on my virtual machine. But I have to execute PowerShell script or commands. So how I can do that? Any idea? Any guesses? First virtual machine deployment that is in under deployment. Second virtual machine deployment is completed. Let's go to your second virtual machine and connect your second VM. Select native RDP. Download your RDP file. Let me run RDP file. Type your username and password. Accept your RDP certificate. As you can see, virtual machine is connected. Now, if I have access of my virtual machine using RDP or SSH, I can easily install web application services inside my virtual machine. But assume if I don't have access of my virtual machine console. In that case, what you can do, let me show you different ways. So either you can use extensions. So if your virtual machine deployment is completed, so left hand side on your virtual machine, you can go to extensions tab. You will create an extension. That means you will create a PowerShell script and you will use extensions. So later also I can use extensions, correct? That is possible. I can use extension first way. Second way, I will go to operations tab and where you can see we have an option to run commands where I can use PowerShell script, and whenever you will use PowerShell script, you will get a terminal where you can directly execute commands inside your virtual machine using PowerShell. So here you can type your PowerShell scripts manually and it will execute inside your virtual machine without having console of your VM, correct? So this will help in troubleshooting. Remember, in production environment, these steps will help you. And no one will teach in Azure administration course, these small things. Okay, so let's go to our console, virtual machine console, and let me open PowerShell. As we already connected our virtual machine, so let me open Windows PowerShell with admin access. And let me execute my first command to install PowerShell. So I can use Server Manager Console as well, which I already shown you how you will use Server Manager Console. So let's try different ways so that we would be able to understand different ways to install and configure services inside Windows Server. So it will install now web server role inside your Windows Server, including management tool. Once this installation will be complete, we will execute second command, and after then third command, and web server will be ready. Meanwhile, let me show you my second deployment is also completed. So let's check second deployment. So as you can see, I already configured this server as a web server through extensions. Any idea what would be next step if you installed web server inside a virtual machine? So how you will access your web server, how you will test that your web page is accessible or not? Any idea how we can do that? How we will test? So first you will copy public IP address of your virtual machine. You will paste into your browser. So now for my virtual machine, I will not get response from my web server just because in VM firewall, port 80 is not open. That means protocol HTTP is not open. So let me go to web 1, left hand side, network settings. Here you can see RDP open, but there is no rule for HTTP. Let's create a inbound port rule. Source any, source port range any, destination any, service HTTP. Click on add. This will be added into your firewall. Then go back to overview tab and refresh your virtual machine console and refresh your web page, your IP address, and here you will get your web page. Let me do the same thing for web 2 as well, just because we have to open HTTP for both servers. So here you can see there's no HTTP rule. Let me click on create inbound port rule, source any, source port range any, destination any, service HTTP, action allow, click on add. This rule will be also added. Here you can see I'm getting response from web 1. So port is open for second VM, and for second VM first command is done. Let me execute next command to remove file, the default file. Now let me execute third command. And we are done with configuration. Let's go to web browser. Let's select public IP address of your second virtual machine and paste into your browser. So here you will get answer from your second virtual machine where you can see web 2. But we have to understand both servers are identical, web 1, web 2, so that we can understand where my load balancer is sending request, correct? But as you can see IP addresses, so I'm able to access both servers on different IP address. What I want a identical front end, identical endpoint where I can send requests, and my request should be distributed to both IP addresses. How we will do that? So we will use load balancer. Now I'm going to create a load balancer. So let me search here load balancers. You will select load balancer service. Where you can see left hand side, you will get all 4 load balancing options. For this lab, we are going to use load balancer. Click on create. Create Azure Load Balancer. Select your resource group. I'm going to use existing resource group. Name of your load balancer. I'm going to give you a name which will be LB1, Load Balancer 1. Region, same, Central India. SKU, we have 3 SKUs here, standard, gateway and basic. Gateway SKU I can use, if you remember, into AWS we have gateway load balancer. So gateway SKU I will use if I have IDS IPS devices. That is intrusion prevention and detection devices. security devices, then I will use gateway load balancer. Otherwise, I will use standard or basic. So in standard, you will get granularity. In basic, there is no SLA. It will be open by default. I'm going with standard. In standard, again, you will get regional and global. But how you will get global? As you can see, global is grayed out. So global is only available for public endpoint. If you will select public, you will get regional and global both. In internal means we are talking about regional. Internal means a VNet, and VNet is a regional service. That's why the global is grayed out for internal. So I'm going with public and I'm going with regional. Why? Just because I'm using this load balancer for a VNet where we have two web applications. So it's a regional service only. So we will select a regional load balancer, but you can use global as well. Now let me go to next, front-end IP address. So let's click on add front-end IP configuration. Name I'm going to give here front-end. For front-end IP address, which IP you are going to use, v4 or v6? I'm going with v4. IP type, single IP address or range of IP addresses. IP prefix means range of IP address 2, 3, 4, 5, 6 based on the CIDR range, like /27, /28. You will get ranges of IP addresses. I'm going with single IP address right now. Let me click on create new public IP address. You have to only provide public IP address name. Rest setting will be grayed out. Correct? As per the recommended setting, it will create a public IP address. So LB1-PIP1, that means load balancer 1, public IP address 1. This would be name of my public IP address. You can give any name, but should be meaningful. Let me click on OK. This IP will be created. Gateway load balancer? No, we are not using gateway load balancer right now. Click on add. This would be my front end. Next, we need to create backend pool where you will add your web servers. So click on add backend pool. Pool name, you can give any name. I'm going to give a pool 1. We can add more than one pool as well. Select your VNet 1. Now how you are going to add your virtual machines, that means your web servers, using their NIC information or using their IP addresses. I'm going with NIC information. Let me click on add. It will discover your both virtual machines, where you can see we have web 1, web 2, and both are having some private IP addresses. So select your both servers, click on add, and then click on save. Click on next inbound rule, where you will create your load balancing rules. So as you can see, first step is add load balancing rule. Click on add load balancing rule. Rule name, you can give any name. I'm going to give you a rule 1. Which IP you are going to entertain, that means if your load balancer will receive request, so your load balancer will receive request from on which IP address, IPv4 or v6, IPv4. Front-end IP address, then after then you have to select your IPv4 address front-end. Click on drop-down. If you remember, we are going to create a front-end IP address, select your front-end. So your load balancer will receive all internet-based requests on IPv4 and this would be your front-end. Next, you have to select your backend pool where your request will be distributed. So pool number 1, which we created. Which protocol you're going to use, TCP or UDP? I'm going with TCP. Now backend configuration. So which backend port you are going to entertain? So port 80. Then source port and backend port. So this would be my backend port, this would be my source port. So users, they will send requests on port number 80 on IPv4 on my load balancer, and this will be distributed to my backend pool on port number 80. Health prop, so load balancer will do health check as well based on your configuration. So right now there's no health prop, we have to create a health prop. So let's click on create health prop and give a name. I'm going to give prop 1. You can give any name. Next, which protocol you're going to use for health prop, TCP, UDP or TCP, HTTP, HTTPS. I'm going with TCP, port number 80, interval 5 seconds. It means after every 5 seconds, your load balancer will send a request using TCP protocol to your web applications. And if load balancer will not receive any response from your web applications, then load balancer will remove those servers from backend pool. And whenever they will be ready, load balancer will add those servers automatically. So it means it will remove and add your server based on their health automatically in the pool. This will be done by a load balancer based on the health check. Session persistence, what it does mean by session persistence? Session persistence means by default load balancer, it will use round robin algorithm. It means it will distribute your request evenly to all endpoints. But what I want, if I have my client IP address, so I can create a sticky session, correct? That is known as session persistence here, where I can use client IP port protocol, these values, and based on that, I would be able to create sticky session, which I'm not going to, oh, sorry, I closed this. Let me create once again. So based on this information, I would be able to create sticky session. Let me recreate health prop. Okay. Idle timeout. So whenever user will send any request to your load balancer, so load balancer will pass this request to your web endpoint, so it will create a TCP session. So TCP session will be disconnected after 4 minutes. What we can do, we can enable a reset here, TCP reset. So whenever our connection will be terminated, it will reset your connection, which you can enable, totally up to you. We have enabled floating IP addresses. Floating IP addresses means if we have multiple front ends, public IP addresses as a front end, we can use floating IP address for load balancing as well. Outbound source net. So whenever we will configure this inbound net, it will be automatically configured destination net here. Let me click on save. This configuration will be saved here. Load balancing rule. NAT rule I'm not going to add right now, but I'll show you once my load balancer will be ready. Outbound rules, I'm not going to add any outbound rule. Let me click on next, review, and create this load balancer. So click on create load balancer. Load balancer deployment will be start and it will be completed in few minutes. So load balancer public IP address is created, load balancer is created. Now both virtual machines NICs are going to be updated just because they will be added in behind the load balancer. Deployment is done. Let me go to my load balancer and let me show you how we can test. So first you need to go to front-end IP configuration from left-hand side. Here you need to copy public IP address of your load balancer, which you can see. Let's copy this IP address into your browser tab and let me paste into chat box as well so that you all can check from which server you are getting response. Let me press enter here. As we can see, I'm getting response from Web2. So I would request all of you to check and let me know from which server you are getting response, Web2 or Web1. I'm getting response from Web2. Web2, okay. What about others? Okay, so let's move to next part. Let me go to my virtual machine tab and I'm going to remove IP address, public IP address of my VM. So let me go to networking tab and let me go to my NIC card, VM NIC card, and let's go to ipconfig 1. Hope you all remember where we can associate and deassociate public IP address on our virtual machine. Let me remove public IP address of my VM2, Web2. So if there would be no public IP address on my virtual machine, it means I cannot access this VM over the internet using RDP protocol. So once we will remove public IP address, as you can see, my RDP will be disconnected. So let's wait for few seconds. It will be disconnected. As you can see, I'm not able to access my server and my RDP connection is disconnected just because I removed my public IP address. Now I cannot access this virtual machine over the internet using RDP just because there is no public IP address associated to my VM. Now assume I have to access this VM over the internet without associating a public IP address. How I can do that? But should be secure way. In that case, just because we have a load balancer here, which have a public IP address, I can use my load balancer public IP address. And through my load balancer public IP address, I can access my virtual machine. How? Let me show you now. So on my load balancer, left hand side, if I'll go to inbound NAT rules. So I will create a NAT rule here for RDP. How? Let me show you. Click on add. Rule name, you can give any name. I'm going to give here web2 RDP, a meaningful name. Type Azure Virtual Machine or backend pool. Backend pool means you can create NAT rule for whole backend pool. It means if in your backend pool, if you have 100 virtual machines, so it will create a rule for all 100 virtual machines, which I don't want right now. I want to create a rule for web2, that means to individual virtual machine, sorry. Then target virtual machine, click on drop down. You have two virtual machines, web1, web2. Let me select web2 here. Network IP configuration, that means you have to select web2 private IP address here. When it comes to NAT, so NAT will map a public IP address to private and vice versa. So we have to select private IP address, then we have to select a public IP address, which you can see your load balancer front-end IP address. After then you have to select front-end port. So before going to select here front-end port, I'm going to select my service tag here. Let me click on drop down and let me select RDP here. It will automatically pick a port here. After then backend port. Backend port will be 3389, that means my RDP port. Protocol will be TCP. So what I'm going to do, if you remember, I'm saying that I'm going to access my virtual machine using a secure way. So what I'm saying, whenever my users, they will send a request on this public IP address on protocol 3389, this request will be sent to this private IP address on port number 3389. It means on RDP port. Simple to understand. Let me do one thing. Let me create a custom port here into source like proxy. So here I'm going to use 50,001. This would be custom port. Now this rule will become more secure as compared to previous rule. Why? Just because this public IP address can be exposed on internet. If it will be exposed on internet, anyone can do port scanning, where hackers can scan RDP ports as well. So I'm going to use a custom port. Let me click on add now here. So whenever I will add this rule, I can access, or users who have knowledge of custom port, they can only access my virtual machine using RDP service. How? I'll show you. Just wait for the rule. Once the rule will be added, I'll show you how we'll do that. As you can see now, rule is added here. Let me show you how we will do that. So I'm going to open my remote desktop service. Let me click on add PC here. You have to simply, if you're using Windows, so you need to open remote desktop and you have to paste your load balancer public IP address. After then column and your custom port. So if you have knowledge of custom port, if you know your custom port, then you can only access your virtual machine, otherwise you can't. Let me click on add here. Let me run this RDP. As you can see, I'm getting pop-up here for virtual machine connection. But what if I'm using only IP address? Just because simply in RDP, we are only using public IP address. If I will use only public IP address, you can see I cannot connect my virtual machine. So to connect so using simple IP address means you're sending request to by default to RDP protocol, RDP port 3389. And 3389 is not open into source just because we are using custom port into source. So let's edit this address and let's use colon 50,001. Click on save. Let me run RDP. Type your username and password. Click on continue. Continue, and you would be able to see I will get access of my virtual machine web 2. That's how we can add NAT rule into load balancer if there is no public IP address associated to your virtual machine. You would be able to access your virtual machine RDP securely by configuring NAT rule. Hope that is clear to everyone. If you have any query, you can ask your question. We are done with this lesson, load balancing lesson. Let's move to next lesson. So we are done with this load balancer, review your setting, configuring your load balancer. We're done with this demonstration. Next lesson, configuring Azure Application Gateway. So when it comes to Application Gateway, we need to understand features of Application Gateway first of all. So Application Gateway, which would be front end for your end users. So this would be your user's web browser, correct? First of all, what I want security. So you will get a SSL endpoint from user's browser to your load balancer. That means HTTPS protocol you can use. So you can purchase a SSL certificate which you can implement for encrypting your user's data. After that, you can use encryption behind the load balancer to your virtual machines, to your VM skillset virtual machines, to your on-prem servers, or to Azure Web Apps. I can use Azure Web Apps as well behind my load balancer. So here you will get granularity. Now let me know what kind of infrastructure we are using here, what type of encryption we are using here. If I'm using encryption from user's browser to load balancer and then behind load balancer as well. So what type of encryption I'm using here? Any idea? Anyone? So this type of encryption is known as end-to-end encryption, correct? Now what I want, and I have to purchase separate certificate for all the servers. That means there would be pricing, where I know that behind the load balancer all communication happens over a private network. That means using a private IP address, where I don't want certificate. So what I want from user's browser to application gateway, connection should be secure, should be encrypted. Behind load balancer we can use unencrypted connection, communication. That is known as SSL offload, or you can say SSL termination, correct? So this feature you will get on application gateway. Again, this will be not a part of our syllabus, but again into AZ 500, that is Azure Security, and AZ 700 Azure Networking, you will get this topic, correct? But AZ 104, we have only introduction of Azure Application Gateway. So it manages your web application request, route your traffic to a pool of web server based on the URL request. That means path-based routing. The web servers can be Azure Virtual Machines or Azure Virtual Machines skill set, Azure App Services, even on-premise server we can add behind our load balancer. So this would be our features where we can do path-based routing. What is path-based routing? You can understand here. So my website is contoso.com. Now behind contoso.com we have two types of content, images and videos. So what we did, we created two pools, pool 1 and pool 2. In pool 1 we have two identical servers which have images content. In pool 2 we have two identical servers which have videos content, images content and videos content. Correct? So what I want, whenever a user from internet, if he will send a request for images into URL, so it should be forwarded to images pool of server. If a user from internet who will send request to videos, so his request should be forwarded to videos pool of server. That is called path-based routing, where load balancer will learn or read your layer 7 content, and based on that request it will forward your request or distribute your request to backend pool. Optionally, we can use web application firewall to protect layer 7 content here. That is called path-based routing. Similarly, we can do multi-site routing or multi-site hosting as well. What it does mean? It means if we have two different DNS, fabricam.com and contoso.com, we can use same load balancer, application load balancer, to distribute our traffic either to Contoso or to Fabricam based on the URL. Correct? Where it can route your traffic up to 100 websites. So using application load balancer, I can route my traffic to up to 100 websites into Azure. So how you will configure application gateway, how you will do load balancing. So we have a simple lab here, which we will test after a short break, and then we will discuss last lesson, network watcher, and this module will be complete. Correct? So let's take a short break. Application gateway load balancer into Azure. So first we need to search load balancer. Then from left hand side on load balancing, you will get application gateway tab. Click on application gateway, click on create. So first of all, resource group, existing resource group M6 RG1, application gateway name. So application gateway name will be FGW1, region Central India, tier. So we have multiple tiers here like standard, standard V2, WEF V2. Based on the tier, you will get features. Like if I'm going to select a standard V2, so I would be able to use static IP address or all advanced features of application gateway like HTTP2 support, WebSocket support. Correct. If I'm going to use web application firewall, so WEF, simple WEF, in which I would be able to use OAuth groups. In WEF2, I would be able to create my custom rules as well, and I would be able to use Microsoft threat intelligence, so based on the machine learning algorithm rules. So again, based on the tier, you will get features. I'm going with standard V2. Enabling auto scaling, in V2 you will get auto scaling as well, which I'm not going to use. Let me select here no. Then instance count 2. Availability zone, you can select zone 1, zone 2 or multi-AZ deployment. I'm going with zone 1 and zone 2. HTTP2 WebSocket support, which you can see that is enabled. If you want, you can disable it. Select your VNet. I'm going to select my VNet. It will create a new subnet inside this VNet. Let me create a new subnet, which would be gateway subnet, application gateway subnet. So subnet name, application gateway. Click on save. After then go back to application gateway tab. Select your subnet once again, application gateway subnet. Click on next front end, where you will add a public IP address. So we can create application gateway which would be public, private, or we can select both. I'm going with public. Let me click on add new public IP address. So IP address name will be FGW-PIP1. That means application gateway public IP address. Click on OK. Then click on next backend where we will add our virtual machines. So let me click on add backend pool. So pool name, pool 1. Add backend pools without target? No. Let me select here. As you can see, we have multiple options here. I can use IP address or FQDN for on-premise and other cloud virtual machines. Virtual machine for Azure Virtual Machine, VMSS, that means we are virtual machine scale set, auto scaler of Azure, and app services. I'm going with Azure Virtual Machines, so I will select a virtual machines. Then click on target, web 1. Second option, virtual machine, target, web 2, and click on add. This will be my backend pool with 2 virtual machines. Let me go to configuration tab where you can see we have added front end, back end. Let's add a routing rule. So click on add rules, rule name, rule 1, priority 1, listener. So listener means who will listen the traffic. So listener name, demo 1, you can give any name. Front end will be public, where on which protocol you will listen your traffic, HTTP or HTTPS. If you will listen on HTTP, no certificate is required. But if you will select HTTPS, then you have to provide your SSL certificate, which we don't have. So we are going with HTTP on port 80. Then port number, port listener type will be basic if we have only single site. If we are going to entertain multiple domains, DNS name, then we will use multi-site. You can provide your error page information as well, which we are not going to provide here. Let's click on backend targets where we are going to configure backend pool as well. So click on drop down, select pool 1, then click on target, click on add new for backend settings, and name will be test 1. You can give any name again. So where on which protocol you want to receive traffic, HTTP or HTTPS. I want to receive traffic on HTTP, port number 80. Cookie based session affinity, again sticky session, that is disabled. So all load balancers by default, they all support round robin algorithm default. Later we can use either dynamic sticky session or manual sticky session. So here this application gateway, it supports dynamic sticky session. So simply you have to enable cookie based affinity and it will enable dynamic sticky session. Connection draining, what it is? Connection draining means if any server which have a existing connection from end user and at the same time you patch this server and you want to reboot that server. So rebooting server will disconnect your TCP connection. It will terminate your TCP connection. So which we don't want. So what it will do, if you will enable this feature, it will graceful remove your servers. When I'm saying graceful, what it does mean? It means if there would be any TCP connection, it will ask you to wait for this TCP connection to terminate. After then your server will reboot. That is called connection draining feature here, which is disabled, which you can enable. You can redirect your request to different document as well, like if any user who is sending request to www.contoso.com and where you want that request should be forwarded to www.contoso.com/index.html, you can redirect your request. Let me click on add this rule and let me click on add. So this would be my routing rule. Next, go to tags, review, and create. Creating application gateway, it will take few minutes. So meanwhile, we are going to our slides. So configuring application gateway, compare with load balancer, which we have already done. Comparison. Let's go to next lesson, network watcher. Last lesson for this module, configuring network watcher, which is a network monitoring tool into Azure. So using network watcher, you would be able to troubleshoot and monitor your Azure networking services, a regional service with various networking diagnostic like IP flow verify. So you would be able to verify your flow from source to destination, diagnose your network connectivity issue using your IP address, port, inbound, outbound. Next hope, determine your IP traffic is being correctly routed and monitoring tools. If you remember, either we can use traceroute command, correct, or we can use this next hope to check that in between source and destination we have a NVA device. If you remember, we already did this lab in module number 5, correct? Sorry, 4, module number 4. So you can use next hop rather than using reset command. We can use flow logs. So flow logs, which will map your IP through a network security group, and you can log your information. Connection troubleshooting. We would be able to troubleshoot our connection based on 4 rules, which I will show you. Topology, you would be able to visualize your topology. You can visualize your topology. Let me show you from where you will get this feature. By default, this feature will be enabled into your region. Let me show you. So if I'll go to my portal, if I'll search here network watcher, so you can see you will get service here network watcher. Left hand side you will get topology tab where you can check your topology. So you can see I have a VNet in which I have a application gateway, I have a load balancer inside my VNet. If I want to check my virtual network, I can click on expand. So whenever you will click on expand, it will expand your VNet, where you can see you have 2 subnets, web subnet and application gateway subnet. So do one thing, click on expand web subnet, where you would be able to see in your web subnet you have 2 web servers, web 1, web 2, which are having 2 NIC cards, and on your NIC card you have public IP address and private IP address, as well as you have an SG network security group associated to your NIC cards. That's how you can check your topology of your network, correct? Left hand side, if you go to IP flow verify, you would be able to check your flow of traffic. How? You have to select your source virtual machine, web 1, interface, then protocol, TCP, direction inbound. Then you have to provide your port number, like I'm going to check my traffic on port number 3389, RDP, and after then let me provide my remote IP address, which would be 10.0.0.5 for my web2 virtual machine, and port number 3389. Let me click on verify IP flow, and you will get response here, that means a result here. If you want, I can show you my second virtual machine IP, private IP address is 10.0.0.5 web 2. So basically I'm verifying my RDP protocol in between both virtual machines, which you can see that is allowed. But how that is allowed? Using my network security group, NSG of first virtual machine, just because target virtual machine is first virtual machine, and on first virtual machine we have a NSG, and in NSG we have a rule: all inbound ports and protocols are open within the VNet. That's why that is allowed. That's how you can troubleshoot. NSG diagnostic, you would be able to diagnose your network security group. Next hop, you can check next hop in between source and destination. Let me show you. So M6RG1 source virtual machine, web 1, then target virtual machine, that means destination IP address 10.0.0.5. Let me click on next hop. Right now there is no next hop in between both virtual machines, but definitely whenever you will configure next hop, you will get next hop, correct? Now effective rules. Effective rules means if there would be multi-scope NSG, that means subnet level and NIC level, you would be able to check your effective rules, which we can check on your virtual machine level as well. Like if I'll go to network settings of my VM, here I will get effective rules tab, which you can see 8 rules are in effect. So similarly, either I can check on my virtual machine or I can check in network watcher as well. Both are same. VPN troubleshoot, I would be able to troubleshoot virtual private network as well. If there would be any issue into my VPN connectivity, I can troubleshoot my VPN as well. Packet capture, similar to Wireshark, I can capture my packets and which I can troubleshoot, or monitor my network. Connection troubleshoot, in which you would be able to see 4 services. Let me show you. Source virtual machine, web 1, select virtual machine, and where let me select my IP address, IPv4, destination port. Let's assume I'm going to check port 80, source port 80. Let me show you, we have 4 tests here which will be performed by this connection troubleshooting service: connectivity, energy diagnostic, next hop, port scanner. Run diagnostic test, it will check port 80 traffic from source to destination based on 4 rules, and you will get result. It will take few minutes. So we can use network watcher feature service to troubleshoot our network infrastructure, to monitor our network infrastructure. We are done with this module number 6.